Obviously, you want to be as accurate as possible in all these things, and the past data obviously helps a lot in uh, constraining the future in terms of how systems work. So we looked at paleoclimates, for example, to understand the range of variability that the Earth has seen based on orbital forcing, tectonic movements, glacial, deglacial cycles, and so on, with varying climate sensitivity. We talked about climate sensitivity and saw that it's not always constant. But also that models are not always very robust in terms of matching observations. But if you look at cumulative extensions as a percentage of the International Union of Conservation Network, I think this is called, that evaluated the species going back to the 1500 into the 20th and 21st century, the cumulative extinction percentage for mammals and birds have gone up almost exponentially. Okay, urbanization, deforestation, habitat destructions, maybe disease pressures, and those sorts of things impact these things. And there is a book called The Sixth Extinction. We have had 5 mass extinctions in the past, which are natural, related to meteorite strikes or flood basalts and so on. And there is a vertebrate extinction, somewhat lower. Fish and other vertebrates, obviously data for the ocean tends to be very sparse, so terrestrial data for some vertebrates could be more available than for the ocean. Much of it remains unexplored. And this is kind of the background level of extinction we would expect if there wasn't a huge human impact. Okay, so after industrial revolution, economic growth, transportation, cutting forests for buildings and trains and trucks and other things, wars and so on, obviously have had their impact. So ecosystem degradation is fairly well documented. Species extinctions are fairly well estimated, but making projections of these into the future is not always easy. This is kind of the example done in terms of trophic interactions for coral ecosystems, and it's looking at basically tropical, extratropical systems. This is just showing the Western Atlantic here. And you can see in 2020 the probability of trophic interactions is high in the tropics, obviously. And as you go into the future, there is something called tropicalization of extratropical reefs. Obviously, ocean warms, the tropics expand, and maybe corals expand, and trophic interaction probability goes up as well. But it's not for everyone. Okay, it depends on whether it's a herbivore, it's a different kinds of fishes, invertivore and omnivore species as considered, and different probabilities of trophic interactions are projected based on this modeling approach. So in terms of the tropical reefs, you can see that there is change expected, projected in terms of the changes in these big species and small species. And how can you verify these? Not always easy. So one has to be careful, especially in terms of action. What are you going to do about it? So coral reefs are already being decimated. For example, the Great Barrier Reef gets bleached during strong El Nino events, but the problem is if global warming acts on top of it, then the natural variability of El Nino may have taught them to respond to El Nino and and recover after the El Nino goes away. But if an El Nino comes and hammers them, then climate change persists on top of that, then they may not recover at all. So these kind of climate stressor adding on to other things is kind of something that's not very well understood. As I mentioned, many people still talk about tipping points. These are basically heuristically argued anyways. So there are things like permafrost disappearing, cascading Arctic tipping points, boreal forest feedback releasing massive carbon, Greenland ice sheet collapse, Arctic they think is already tipped over and into an irreversible state. Hard to put uncertainties on these things. That's my main objection to these sorts of arguments. West African monsoon, Indian summer monsoon, coral reefs, West Antarctic ice sheet, it's tapped here as already tipped. Ocean acidification and deoxygenation we haven't looked at much, but if you keep increasing carbon dioxide in the atmosphere, the carbon dissolves into the water easily and acidifies, which is not good for calcifying creatures like corals and shell-forming zooplankton and phytoplankton, because then they dissolve or they don't grow as well. They have deformations and so on and so forth. Amazon rainforest is argued to be a tipping point. It's already switched from a carbon sink to a carbon source by 2017 according to some estimates. Again, high uncertainties. El Nino Southern Oscillation, we already talked about how models are not depicting this properly in terms of the relative warming of the East Pacific versus the West Pacific. So you make your call based on your own knowledge and read up as much as you can to decide whether you can estimate the uncertainties in some of the conclusions drawn from existing observations and models about systems having already tipped over or being very close to the tipping point and so on. I will be honest, I'm not very comfortable with those, okay? But you have to make your own call.